We're going to continue with transformations, and we're going to talk about the order in which we perform transformations on a function. So here in f of x equals -4 minus x squared, what are the transformations? That -4 being outside the function means it shifts down 4. And that negative multiplied by the x squared is a vertical reflection, so it's going to flip over the x-axis. Okay, so there's two graphs here with the square function already on them. We are going to perform the two different transformations on graph A in this order, shift and then reflect, and then on graph B, reflect and then shift. Okay, so shift down 4 means we're going to take every point on this graph and shift it 4 units down. There's also one up above here at 3,9 and -3,9. So we're going to shift down 4 units. So it would look like that after shifting down 4 units. Then we are going to reflect it over the x-axis. So every point gets flipped over the x-axis, so this one that's 4 below will become 4 above. And then these that are 3 below will become 3 above. These that are on the axis will stay. And these that are now 5 above the axis will become 5 below. So the final graph is going to look like that. Now this time we're going to do the reflection first and then shift down 4. Okay, so this point is going to stay right there. These 2 points that are 1 above are going to go 1 below. The 2 that are 4 above are going to go 4 below. And way up here, 9 above are going to go 9 below. So it's going to look about like that. And then it's going to shift down 4. So everything goes 4 units down from there. So the final graph is going to look like that. So does order matter? Yeah, it definitely matters. Does order matter with transformations? Definitely yes, because when I change the orders, the graphs did not look the same. So let's go to the calculator and see which one is correct. So y equals -4 minus x squared and graph. So it looks like this one is correct. So on your calculator, which graph is correct? B, which means graph A is not correct. So the order definitely mattered. We had to do this multiplying by a negative before subtracting. Well, it's just like order of operations. Multiplying by anything comes before adding and subtracting. Okay, so there is an order that we must follow. And that order is like order of operations. Remember, parentheses, exponents, multiplication and division go together. Addition and subtraction go together. So the first thing that we have to do is inside, typically it's going to be inside of parentheses or inside of some kind of grouping symbols. Inside goes first. And when you're inside, you look for multiplication before addition. Then you go outside of the function and look for multiplication before addition. Okay? So the typical order for most transformations is going to be a horizontal, dilation, and reflections, you have that same priority because it's multiplying by a negative. Second, you're looking for a horizontal translation. Okay, so those things go first, and remember that those numbers have the opposite effect when it's inside. Okay, so minus means go right, plus means go left. Multiplying by a 2 means half as wide. Multiplying by a 1/2 means twice as wide. The third thing you're going to look for is now you're going outside the function and you're going to be multiplying first, so you're looking for vertical dilation and reflection. And fourth, you're going to be looking for a vertical translation. And remember that these go at face value. Plus means right, minus means left. When you have absolute values, you treat the order like they're parentheses. I'm just going to put a picture of parentheses here, or brackets, or any kind of grouping symbols. So a combined equation that shows the 4 basic transformations that happen most often. Okay, the first thing that you're looking for is a horizontal dilation. And that is right there. Okay, by a reciprocal. The next thing you're looking for, staying inside of the function, is a horizontal translation. Right there, opposite the sign. The third thing is a vertical dilation. So you're moving outside and looking for multiplication right there. And the last thing is vertical translation. And that's adding or subtracting a number outside of the function. Okay, so we are going to first list what things happen in the correct order and then try to graph. So first we look inside of the function. So that's right in here, and I see a +3, so I know for the first thing is going to be shifting left 3 units. So I can take all of these coordinates and shift them 1, 2, 3 units to the left. Okay, so that's where it would be shifted 3 to the left. Okay, the next thing is to shift everything up 2. So all of these points that have been shifted already to the left are now being shifted up 2. Okay, and it does say compare with the results with the calculator, so let's graph that. All right, so we're shifted 3 to the left and up 2. That looks about what I've got on that graph. All right, so next. It looks like a horizontal dilation, and that's 0.5, which is 1/2. And when you do a horizontal dilation, it is by the reciprocal. So horizontal dilation by 2. So that means every x value gets doubled. An x value of 0 is going to stay 0. An x value of 1 is going to become a 2. Negative 1 is negative 2. An x value of 2 becomes 4. Way up here at 3, 9 and negative 3, 9, that's going to be doubled to 6, 9 and negative 6, 9. So there's my horizontal dilation by 2. And then I've got a plus 2. So it looks like left 2. So all of my coordinates should just move 2 units to the left. So we'll go back to our graph, clear that out, and type it in. Okay, and that does not actually appear to match the graph, because this looks more like the vertex is 4 to the left, while I've got a vertex here of 2 to the left. So I'm going to have to say, you know what, that's wrong. So what went wrong there? Well, 4b has the same equation, and here's the problem. When you have a horizontal dilation and translation in the same equation, or in the same function, you actually have to factor that dilation out. So that 0.5 is factored out of this 0.5x plus 2. Okay, so what is 2 divided by 0.5? Well, that is 4. And I'm going to run out of room here. So we'll just pretend that showed up nicely. So I've still got the horizontal dilation by 2. But after I factored out that horizontal dilation, I found that I should actually be going left 4. Okay, so I'm going to double all my x values like I did before. So there it is after that horizontal dilation by 2 again. But now I need to shift everything left 4. So it looks more like that, and that matches what I've got in the graph. So we've got to be careful when we have a horizontal dilation and a horizontal translation. We have to factor out that dilation. All right, so on to page 2. From the parent function, f of x equals x squared. So we're doing a square function, a basic parabola. Describe the transformation, and then check with the graphing calculator. We're just going to go through each one and describe the transformation. So negative 2x squared. So there are two things that are happening here. They're both multiplication. Multiplication by a negative and by a 2. And both of them are outside. So there's nothing inside of this squaring. So they're both outside. And what we'll do here is just work our way from the closest out to the farthest. So the first thing that happens is a vertical dilation. And when things are outside the function, they're vertical. They're just at face value. So by 2. So this thing gets 2 times taller than the original. And then multiplying by the negative, there's a vertical reflection, which means we flip over the x-axis. So it gets twice as tall, and then it flips over the x-axis. Okay, so this time we've got negative 3x squared plus 2. Once again, there's nothing inside of that squaring. So we're going to do these two multiplications, working our way from the inside out, and then we'll worry about addition. So the first thing that happens is a vertical dilation by 3. Then it's multiplied by a negative also outside, so it's going to flip over the x-axis, a vertical reflection. So far, it's gotten 3 times taller, then it's flipped over the x-axis, and then that plus 2 means it is going to shift up 2 units. Okay, again, there is nothing inside of that squared function. I know there's parentheses, but the squared isn't out here, so there's nothing inside of the square function. We're going to work our way from that x out to that 3. So the first thing is a vertical dilation by 3. So it got 3 times taller. But then I have to finish up inside these parentheses before I can do that negative. So that minus 1, again, it's not inside the squared's not here, so it's vertical again. So that means it goes down 1. Now I can move outside of the parentheses. I've been outside of the function the whole time, because the function is just this right here, the x squared. I haven't been inside the function at all, even though I've been inside parentheses. But now I move outside the parentheses, and that negative means a vertical reflection, so I flip over the x-axis. So it got by 3 here, so it got 3 times taller, then it shifted down 1, then it flipped over the x-axis. Okay, so that squared function in this one, I'll just make a rough sketch of it. It got 3 times taller, and then shifted down 1, so it kind of looked like that, and then it flipped over the x-axis, so it would look like that. This last one in this section, I see 1, 2, 3, 4 things that are happening to it. And the squared is here, which means anything that's being squared is inside of the function, so I do those things first. First thing is that multiplying. There is a horizontal dilation by the reciprocal, by 1/3. So it actually gets 1/3 times its original width, so it gets skinnier. Then that plus means it's going to shift left, but remember, when there is a horizontal dilation and translation, I have to factor. So that's the same as 9 plus 1/2 times 3 times x plus 7 divided by 3. So I factored out that 3. Okay, so you don't really have to write this every single time, but just know that you have to do 7 divided by 3 to find the translation. So that translation of plus means it goes left 7/3 of a unit. Then we move outside and do our multiplication. There's a vertical dilation by 1/2. So it gets 1/2 its original height, and then it shifts up 9. All right, f of x equals 1 over x. So a general sketch, it looks about like that. Multiplying by 0.2 on the outside, Okay, so that is not inside of that function. That is the same, by the way, as 0.2 times, and 1 over x is x to the negative 1 power. So that 0.2 is not inside of that x to the negative 1 power. So that is vertical. It is a vertical dilation by 0.2. Right? Or you could say it's by 1/5. So it gets 1/5 its original height. Now this one is inside the function. Okay? So this is the same as 0.2x to the negative 1 power. Okay, so that one is inside the original function, so it is a horizontal dilation. And it's by the reciprocal. Now that 0.2 is the same as 1/5, so it's by the reciprocal, which is 5. So it gets 5 times the original width. All of the x values get multiplied by 5. Okay, here I've got two things happening. First, inside the function is a 5, and I'm multiplying. So that is a horizontal dilation by the reciprocal of 5, 1/5. And then, outside the function, it shifts down 3. And here I see two things happening. Nothing is inside the function, so there's nothing in there. But if I move my way out, I see that it's being multiplied by a negative, so that is a vertical reflection, which means it's going to flip over the x-axis. Okay, so it used to look like this, the original. When it flips over the x-axis, what was up here moves down here. What was down here moves up here. Okay, then it's got a positive 2 here, which means it's going to shift up 2. So it's going to look like this. Okay, so these won't be there anymore. All right, number 7. F of x equals the square root of x. Okay, so just a reminder, it looks roughly like that. So two things happen here, and they both are inside of that square root. So they are both horizontal. The first thing is multiplying, so that's a horizontal dilation by 1/2. Then there's a plus 5 in there, so it's going to move left. Remember, it doesn't move left 5, it moves left 5 over 2. So it moves left 5 halves, or 2.5. And here I see three things happening, a 3, a 2, and a negative 5. So this is an absolute value function, so it looks roughly like that. First thing is a horizontal dilation with that 2, so it's by 1/2, so it gets half as wide. Then that minus means it moves right 5 over 2. And that 3 outside means it moves up 3. What if that was a minus right there? Well, then the third step would actually be flipping over the x-axis. Then it would still move up 3 because that 3 still is positive.